Are we alone in the universe? This question has captivated scientists for centuries, sparking the curiosity of people everywhere and inspiring countless other inquiries into the great unknown. Many researchers believe that Earth is not the only place in the cosmos where life exists. Given the universe's staggering scale, an estimated 2 trillion galaxies, it might be more practical to ask, are we alone in the Milky Way? According to a new study published in the Astrophysical Journal, researchers from the University of Nottingham suggest that our home galaxy could host around 36 communicating, intelligent alien civilizations. How did they arrive at such a specific number? The authors describe this estimate as conservative, basing it on the assumption that intelligent alien life emerges on other planets under conditions similar to those on Earth. They presume our world is not exceptional. If a planet like ours orbits a star like our Sun and follows a comparable developmental timeline, taking around 5 billion years for intelligent life to form, then there should be at least 36 Earth-like civilizations within the Milky Way. Previous attempts to estimate the prevalence of extraterrestrial civilizations often relied on the Drake equation, which involves 7 factors determining the number of communicative alien societies. However, past estimates were wildly variable, ranging from 0 to several billion. By refining the calculations with updated data and more grounded assumptions, the Nottingham researchers concluded there are likely between 4 and 211 such civilizations, with 36 being the most probable figure. But detecting these civilizations remains a formidable challenge. Many would be thousands of light years away, making direct communication or observation extremely difficult. Still, we can begin our search by examining intriguing nearby worlds, starting with Proxima Centauri b, the closest exoplanet that might harbor alien life. Proxima Centauri b resides in the habitable zone of its star, Proxima Centauri. This so-called Goldilocks zone is the region where conditions are just right for liquid water to exist on a planet's surface, neither too hot nor too cold. Proxima Centauri b is similar in size to Earth, roughly 1.17 times Earth's mass, and likely only about 10% larger in diameter. The planet may be tidally locked, with one side perpetually facing the star and bathed in constant daylight, while the other side remains in eternal darkness. This creates 3 potential climate zones: a hot, sun-facing side, a cold, dark side, and a temperate twilight zone in between. If life exists on Proxima Centauri b, it would have had to adapt to these extreme conditions. On the forever-lit side, organisms might harness the continuous stellar radiation for photosynthesis-like processes, while on the dark side, life might depend on geothermal energy or other heat sources. If intelligent beings inhabit Proxima Centauri b, it would imply that such life is relatively common, considering there are an estimated 400 billion stars in our galaxy. The odds that the only 2 intelligent species in the galaxy happen to be neighbors would be astronomically low. The existence of advanced alien life there could also inform us about the nature of interstellar travel. If we've received no visitations or signals, it might mean that even highly advanced civilizations find interstellar journeys daunting, or that they are less developed than we are, making us the potential first interstellar visitors. However, these ideas remain speculative until we confirm the existence of extraterrestrial life. Another intriguing candidate is Kepler-62e, located about 12 light-years away. This super-Earth is about 1.6 times the size of our own planet and orbits in the habitable zone of a smaller, cooler star. There's a strong hypothesis that Kepler-62e could be a water world, possibly covered entirely by oceans. Such conditions might foster aquatic life forms, although the development of a civilization like ours would be more challenging under entirely oceanic conditions. Nonetheless, we currently lack the technology to study Kepler-62e in detail. Gliese 667cc, GJ 667cc, is another super-Earth candidate, roughly 23 light-years away, orbiting in a triple star system. Observers standing on its surface might witness 3 suns in the sky. Its host star is a red dwarf with a lifespan far longer than that of our Sun, offering a generous time frame, up to 150 billion years, for life to arise and evolve. Even if life does not currently exist there, future conditions could someday be ripe for its emergence. With 3 potentially habitable planets in the Gliese 667 system, it becomes an even more compelling target in the search for extraterrestrial life. Kepler-22b, about 640 light-years distant, is yet another intriguing world. A super-Earth about 2.4 times Earth's radius. Its nature, whether oceanic, rocky, or even somewhat gaseous, is still uncertain. Should it be an ocean world, it might host an alien marine biosphere. At such extreme distances, we are peering deep into the past. Any hypothetical observer on Kepler-22b aiming instruments at Earth would see our planet as it appeared around the year 1384. As vast as 640 light-years seems, it still represents less than 1% of the Milky Way's diameter of roughly 100,000 light-years. Our exploration of potentially habitable exoplanets has barely scratched the surface. Data from the Kepler Space Telescope suggests there could be up to 300 million potentially habitable planets in our galaxy alone. With so many worlds to consider, an estimate of just 36 alien civilizations seems exceedingly conservative. If every galaxy hosted only a single intelligent civilization, then, given the estimated 2 trillion galaxies in the observable universe, there would be at least 2 trillion civilizations. Such numbers are humbling. Our own civilization could be just a tiny speck against the grand cosmic backdrop. As we peer into the cosmic ocean, we are left to wonder, what legacy will we leave behind, and who might someday learn of our existence?